Good day, I am Edric Ato, ID 121, and I'll be teaching CALENG2 quiz number 3. The topic that I would be discussing today would be work of a pump on a liquid. So, let's get right to it. The problem is stated as follows. An 8-long trough is filled with water of a density 62.5 pound per cubic foot. The ends of the trough are semicircles of diameter 4 feet. Find the work required to pump the water out at the top of the tank. Note, please place the top of the trough along the x-axis. So this would be the x-axis. Let's take this as the y-axis. Now for ease, we could use something like this. This is our trough. This is a diameter of 4, so this must be negative 2, 0 and 2, 0. So this would be 0, negative 2. For ease, we're going to make this look symmetric. Since this is going to be a semicircle with the center at 0, 0, first we have the equation of a circle, x squared plus y squared equals r squared. Since our radius is 2, that is simply going to be 2 squared or 4. Now let's solve for y. Y squared is equal to 4 minus x squared. And take the square root. Y is equal to square root of 4 minus x squared. Now, actually, even though that this is a semicircle, this is actually the positive side of the semicircle. So, we're going to add a negative side here. Let's also, so this is going to be y is equal to negative square root of 4 minus x squared. The formula for the work of a liquid is equal to the integral from a to b of rho s dv. We're going to talk about what those mean later. So a is our lower limit, which is going to be simply negative 2. And our b is simply 0. A and B should be the limits of the tank itself. Rho is going to be the density, that's 62.5. S is the distance from the water level, or the level that the water wants to go, minus the absolute bottom of your container. So, since our container wants to go out at the top of the tank, and the top of the tank is at the x-axis, or y equals 0, the top of S is going to be 0 as well. And our element is going to be minus y. Lastly, our dV is our differential volume. This is simply the length of the trough times the width of the trough times your differential height. The length of your trough is going to be, is already given actually, of 8 feet. The width of your trough is actually going to be 2 times the equation of the x. So let's try to solve for x here. We're going to get negative y is equal to square root of 4 minus x squared. So, y squared is equal to 4 minus x squared. X squared is equal to 4 minus y squared. And x is equal to square root of 4 minus y squared. We'll take the positive x here since it's actually symmetrical. this is equal to 2 square root of 4 minus y squared. And simply our dh is equal to dy. So, substituting, we would get the integral from negative 2 to 0 of 62.5 times 0 minus y is negative y times 8 times 2 square root of 4 minus y squared dy. Let's take out all of the constants already. So it's 62.5 times 8 times the integral of negative 2 to 0 of, so there's also another 2 here, of negative, or we could also take out the negative sign. Negative 62.5 times 8 times 2 times the integral from negative 2 to 0 of y square root of 4 minus y squared dy. Now let's use u substitution here. Let u be equal to 4 minus y squared. So du is actually equal to negative 2 y dy. We already have y here, y dy here. So we only need to multiply negative 2. Thankfully, we also already have negative 2 here. So that would be 62.5 times 8 is the integral of, we also need to change our limits. So u here would be from 0 to 4 this time. Okay, 0 to 4, square root of u du. Why 0 to 4? We changed up our variable. We said u here is equal to 4 minus y squared. So our lower value is u equals 4 minus negative 2 squared. So it's 4 minus 4, or simply 0. Our upper value, we substitute 0 to y. So it's 4 minus 0 squared. We're getting 4. This equal to 62.5 times 8 times the integral times, let's already evaluate the integral. This would be u square root of u over 3 halves evaluated from 0 to 4. Since 0 is the lower limit, we could just simply substitute 4 to the equation. So we have our work be equal to 62.5 times 8 times 2/3 times 4 square root of 4. So evaluating this, let's evaluate this. This becomes 62.5 times 2 first. This is 0.25. 125. Is that divisible by 3? I don't think it's divisible by 3. So 125 divided by 3 times 8 times 8. Because 4 square root of 4 is simply 8. 125 times 8 first. We get 40, 16, plus 4, 20. 1,000 over 3 times 8. We get 8,000 over 3. And since this is work, density times volume is your weight. So it's pound. So this is pound foot, or foot pound. So 8,000 over 3 foot-pounds. That is our final answer. I hope you learned a lot in this video. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is Edric Ato from Syntax, paving your way to excellence.